So good morning and welcome to day 18 of neurology, and today we'll be discussing cerebellum, right? Literally that chota dimag, but so important. So today what we'll do is most of the things they are graphical and we'll be focusing on anatomy, right? Anatomy. At the same time, we'll be watching the blood supply, nucleus, all the things in detail. Will not be, say, touching any of the clinical aspect today, because as such cerebellum is so important that it will require one complete full session, and at that point of time when we'll be discussing the clinical part, it is very much important that we should be very properly aware of all the anatomical structures, right? So that's the reason today we'll be focusing on anatomy, and in the next session, that is the cerebellum part 2, that is where we'll be talking about the clinicals, right? And clinicals will take in more detail along with all the tests, how it is done, and along with all the tracks, right? So let's start with our today's discussion, and this is the cerebellum, right? So here it is, that's the brain stem. In brain stem, midbrain, pons, right? Pons, medulla oblongata, and the cerebellum, that is situated posteriorly. This is our fourth ventricle, right? As you are very well aware of it. And this one would be the quadrageminal plate, superior colliculus, inferior colliculus, pineal gland. Now you know all those things pretty well. Here is, this one is the cerebellum, right? This entire thing is cerebellum. Now in cerebellum, it is separated from this occipital lobe, right? This one is the occipital lobe of cerebrum, and in between what we get, and that is the tentorium cerebelli, right? During meninges we talked about it, right? Tentorium cerebelli. So that's the location of tentorium cerebelli. In cerebellum, right? In cerebellum, say it is divided into a very specific structures. So what we'll now do is, let's understand its connectivity with rest of the brain, because this is very typical, right? We saw that this is posteriorly situated, right? So this is posterior to pons and posterior to medulla oblongata, right? Because it is posterior to our brain stem. So obviously this is situated into posterior cranial fossa, right? So this is part of posterior cranial fossa. Important part is that it is called as the cerebellar peduncles. Now, step by step, we'll keep on adding new terminology, right? So this is cerebellum, and as we said that this cerebellum would be connected to various parts of brainstem, and they are called as the peduncles, right? Peduncles. So there would be one superior peduncle, there would be middle peduncle, and there would be inferior peduncle. We'll be going into the detail of that, what exactly connects with what and which are afferent and which are efferent, right? But putting into simple words, superior, middle, and inferior peduncle, we'll see them, right? And all of them, they are connected with brainstem and spinal cord. Why it should really happen, like everyone is getting connected to cerebellum? Sorry. The reason behind it is that all these peduncles, right, they are not just the structures, but in fact they are large bundles, right? They are large nerve fiber bundles. So they are large nerve fiber bundles. So when we understand that they are large nerve fiber bundles, right? So, and they are present on both the sides, right? They are bilateral. So they are bilateral, present on both the sides. That means it will be carrying some very important information towards the cerebellum. And function of cerebellum is very, very superb, right? The function of the cerebellum, it is the fine control. right? Cerebellum will never be sending any of the messages directly to any of the limbs. No. But what it is doing, it is fine tuning. It will fine tune the movements. So all the fine movements, right? Coordination, when you say, right? Coordination. That's why when we'll be testing clinically, right? Say for example, we'll say, okay, close your eyes and try to stand straight, right? Try to touch your nose, right? So these are some very specific movements. So whether there is overshooting, whether it is, so are they maintaining the balance, what's the posture, right? Just remember these keywords, because all the clinical sign symptoms and all the clinical tests, they will be associated with it. Reason that this is our chota dimag or cerebellum, and with cerebellum everyone is connected, right? There would be tracts, peripheral receptors, right? They will be sending information to cerebellum, right, via spinal cord, right, via spinal cord. So if there is a spinal cord and there is cerebellum, you want to name that track. What name would you like to give? Well, start to end. It is starting from spine, the spino, ending on cerebellum, the spinocerebellar tract. So easy, है ना? So when we'll be discussing the tracks, right? So as such, it is said that two things, they are very tough. One, the basal ganglia, which we have finished, right? You have understood it quite properly. Cerebellum, right? It is not complex, but it is very specific. We'll try to make things very simple, right? Just by understanding that where exactly are those peduncles. Then say just this page, whatever I'm writing on this page, right? That would be crucial for all the tests, right? Then from spinal cord, say we said that it is the spinocerebellar tract, right? Then from visual, right, there would be vestibular apparatus, right? Vestibular apparatus. All of them, they are sending information to cerebellum, right? From cerebrum, it would be sent, right? From brainstem, it is going brainstem. So that means everyone is coming over there to cerebellum, and this is how it is going for fine tuning, coordination, balance, posture, and one of the biggest thing, plus the motor learning, right? It is motor learning. Now in motor learning, see why it is said that your brain will remain very active if you try to learn a new language, right? This is the reason, because so many centers they are involved, right? So language learning, great, right? So this is how cerebellum is linked. Now let's do one more thing. We try to make those peduncles part very easy, right? So here is, say, cerebellum, right? Here is our cerebellum, and over here rest of the structures of the brain, okay? So we connect it like this, this, and this. This would be superior, this one would be middle, and this one would be inferior cerebellar peduncles, right? So I'm not writing, but we just say these are all cerebellar, and we are talking about peduncles. Peduncles. So this is the superior cerebellar peduncle. Superior cerebellar peduncle will talk straight away to thalamus, right? It will talk to midbrain, and in that, so these are all going out. So these will be the efferent channels, right? So they will be going out. They are the efferent channels, right? In this, you must remember one nucleus. This nucleus right now, just keep it in mind. It is called as dentate, but as such, we'll be discussing all the nuclei, right? So this is the dentate nucleus, which is involved into this part. This is the efferent part, right? What about What about this middle cerebral peduncle? For middle cerebral peduncle, we have to change the arrow. We have to change the arrow. Things are absolutely specific. So this is about the pons. There is a nuclei, pontine nuclei, right? Pontine nucleus. Pontine nucleus. But this pontine nuclei is of opposite side. Very important clinically because things would change over here, right? That the which side the lesion is. So these will be the, say these will be the efferent. So these will be here. These are the afferent fibers, right? These are efferent fibers. These are afferent fibers. So afferent fibers from the pons, they will be going into the cerebellum via middle cerebellar peduncle, right? So this is very clear. Regarding the inferior cerebellar peduncle, again, we have to change the direction of the arrow, right? Why we are changing? Because this is also afferent. Afferents are arriving, right? Afferents, they are arriving. Efferents exit, right? Efferents go out, afferents arrive. Makes sense that when the middle cerebral peduncle is to pons, so inferior cerebral peduncle will be below. So the structures which are below the pons, right, that is none other than medulla oblongata and the spinal cord. Right? And in this, yes, you are right, that spinocerebellar tract. Let's be specific. This is a posterior spinocerebellar tract. So the keywords which we are taking along with us is that superior cerebellar peduncle, it is efferent. It is going out towards the thalamus and midbrain. Now imagine how beautifully the whole thing is designed, right? Middle and inferior cerebral peduncle, they are collecting the information, and then that piece of information that is really sent to thalamus and midbrain for the further actions, right? All these peduncles, they have got some extra names also. Say for example, superior cerebellar peduncle, it is also called as the brachia conjunctiva, right? These are just the other name. So brachia conjunctiva. Then this middle cerebral peduncle, that is also called as pons, so it is called as the brachia pontis, right? It is called as the brachia pontis. And this last one, which is, say, inferior cerebral peduncle, that is called as the restiform body, right? It is called as the restiform body. Sorry. So that's how these cerebral peduncles, they are associated. Now about how this cerebellum is divided. For that, we'll first draw a very basic figure, right? Just a basic figure, this. And here is our fourth ventricle, right? That entire one is brainstem, so pons, medulla oblongata, right? Medulla oblongata, etc. And as we said, this is a posterior structure, right? So that's our cerebellum, right? In this, just making it slightly smaller so that we can write. So we make it, so this is the cerebellum, right? So there would be one primary fissure. Right? This primary fissure will divide the whole cerebellum into two parts, anterior lobe and posterior lobe, right? So this is the anterior lobe, and the rest is all posterior lobe, right? So far, so good, right? So this one is anterior lobe, right? And this one would be the posterior lobe. But there is one more lobe. So we have to draw it like this. This one, very small. This is called as flocculonodular nodular lobe. Flocculonodular lobe. So there has to be a fissure in between, because that is the fissure which will divide, which will separate it from this posterior lobe, and that is called as the posterolateral fissure. Posterior and lateral, right? So this is called as the posterolateral fissure, right? Now, to make things easy, as such, if you see this primary fissure, right? This primary fissure, right? This primary fissure is dividing it into two parts, right? One, what is anterior lobe, and second one which is posterior lobe, right? But this posterolateral fissure, it is dividing into flocculonodular node and the posterior lobe. Just for this, anterior lobe and the posterior lobe, right? Lobes, these are lobes. Anterior lobe and posterior lobe, the whole one, it is collectively called as corpus cerebelli. Corpus cerebelli. Because this flocculonodular lobe is a special one. The moment we'll see it, we'll understand, right? So this is about the main fissure, how this cerebellum is divided. So let's start with some really good images. This, every time I'll keep on writing which view it is. Now see, this is anterior view, right? Anterior view. Why do we say anterior? Because this is pons, right? And pons is right in front. So pons, medulla oblongata, they are over here, right? This is medulla oblongata. This would be the olive, right? We'll discuss olive and olivary nucleus when we'll be talking about this medulla oblongata. But this is in front. So this is pituitary, right? This is infundibular stalk, right? Infundibular stalk. Then say obviously the upper part, that would be the hypothalamus, right? You remember this. So this portion, this one is cerebellar peduncle. Cerebellar peduncle. This is anterior view, right? So we have kept rest of the brain, rest of the cerebral cortex has been removed. Just we are keeping the entire midbrain, and behind it, it is the cerebellum. So this portion, this above one, that's our anterior lobe, right? Anterior lobe. And this rest of it, this entire one, that is the posterior lobe, right? That is the posterior lobe. Question might arise that what is this? Which fissure is this? We'll come to that, right? Just hang on. And this small one, that's the flocculus or the flocculonodular lobe, right? So this is flocculonodular lobe. So this flocculonodular lobe, anterior, posterior, so right? So these are the three lobes. When we are watching it from the front. Now we change the view. Now we are watching the same structure from the lateral sides, right? So this is our lateral view. So that's our lateral view, watching it from the side. Easy. This is just pons. It cannot be anything else. Medulla oblongata, olivary nucleus, that's fine, right? This is pituitary, right? This is pituitary gland. Then this one would be, yes, infundibular stalk, right? Infundibular stalk. And this top, that is the place where there will be the hypothalamus, right? Hypothalamus. And this one is cerebellar peduncle, right? So when we'll be taking a section, at that point we'll see that how this portion is actually having three bundles, one superior, middle, and the inferior one. This one, sorry, anterior lobe. This whole thing, right? That below, that is the posterior lobe, correct? Posterior lobe. So this fissure which is in between, that would be the primary fissure, right? We have not yet talked about this biggest one, the biggest fissure, that is this one, right? Chalo, at least let's give the name. Its shape itself is telling that it is horizontally placed. So this is what is called as the horizontal fissure, right? Horizontal fissure. What it divides, just hang on, right? At this point of time, we'll call this as also a posterior lobe, and even this is also a posterior lobe, right? They both are posterior lobe. Clear? This one is flocculus. Flocculus, right? You might ask, flocculus or flocculonodular lobe? Flocculus, right? Because in cerebellum, these are the two hemispheres, and then in between area, it is what is called as vermis. And vermis is that area where the things will be divided into multiple layers. And then with every part, there would be an associated lateral structure, right? So this flocculus will be having associated lateral structure, and that collectively the whole thing will be called as flocculonodular node, right? So it's sort of tongue twister, right? Flocculonodular lobe, okay? Anyway, let it come, right? It will come. Acha, here it is. Another image. Now this is, you must have guessed, this is a posterior image, right? Posterior view, right? That orientation is so vital. This is a posterior view. We are watching from the back. So that top is hypothalamus, and we are watching the whole structure, right? And this is the medulla oblongata, which is in front, right? These are cerebral peduncles, right? Achha. Meantime, this, right, that is anterior lobe, right? Anterior lobe, and this whole thing is the posterior lobe. Posterior lobe. Think of this horizontal fissure, right? Horizontal fissure. Now you need to visualize a bit. This is the horizontal fissure, right? Literally horizontal. But when we rotate it, right? When we rotate it, so here it is. So this means on the lateral aspect also it is seen. So all the way from sides, right? All the way from sides, and it goes posterior, right? You got it? All the way from the sides, and it goes posteriorly. So this is the lateral view, and here is, it will give the posterior view also. It is seen fully, right? I just remove this thing from here. So that's the horizontal fissure, right? It is dividing the posterior lobe. There is something which is over here, which is just protruding. This is called as tonsil. Tonsil of cerebellum, right? This tonsil of cerebellum is continuous with posterior. This is the posterior lobe. So it is continuous with the posterior lobe, right? And this portion, this one which is in center, this portion which is in center, right? This elevated one, that's called as vermis. Vermis. Vermis means worm-like. So this is a sort of worm-like, right? If you take out the whole vermis, so it looks like a worm. So that's the reason that it is called as the vermis or worm-like. Worm-like. Good one, right? Let's take another view. Yes. This view, right? This is as if you are watching from the top, right? So this one is our hypothalamus. Hypothalamus, right? So on the top there is hypothalamus. Underneath, right? Underneath this small portion there would be the pons. Then still underneath there would be medulla oblongata, and then the spinal cord, etc. So this one is the anterior one, anterior lobe, right? And this one is the posterior lobe, posterior lobe. And this is our superior view, right? So superior view. How about this? Immediately we know that this is nothing but spinal cord, right? See the shape itself, and inside we can see all those, it's like a cut section of spinal cord. So this is inferior view, as if we are watching from below, right? So this is inferior view. Great. Right. So now all the structures, medulla, this is pituitary, this is infundibular stalk, right? Then spinal cord, medulla oblongata. These are tonsils, right? These are cerebellar tonsils. And no wonder this one would be the posterior lobe of cerebellum, right? In between, what we are getting, this is vermis. Now, vermis is seen here also. Vermis was seen in the superior image also. Vermis was seen in the posterior also. Vermis is like this, right? This one image, one drawing will make everything easy. This is how the vermis is situated. This is, right? That's vermis. It is the central portion which is connecting both hemispheres of cerebellum, right? So in superior view, right? In superior view, you watch the vermis. In posterior view, so you watch full vermis all the way from top to bottom. And in inferior view also, you watch the vermis, right? Here it is. So this is the end, right? This is the end. So here is, this is the end. So that's how. So if here is the cerebellum, right? So vermis will be all the way from top to bottom, superior to inferior. Now watch it. Inferior you have watched. Let's watch posterior view and the superior view again, right? See the superior view. Here it is vermis, the beginning of the vermis. This is superior view, right? So the vermis has started, right? This is start of vermis. Start of vermis, right? Then let's watch it in posterior view. Here it is full-fledged, the entire posterior view, right? So the in top view, from here there was start, right? Start of vermis, and then that vermis will go beneath, and that's what we watch, right? These are the cerebral peduncles. I'm sorry, tonsils of cerebellum, right? Peduncles are here. So these are the tonsils, and in the inferior view, we were watching tonsils very properly, and in between the vermis was landing and it was ending. Here it is, right? So these are the cerebellar tonsils, and the vermis is ending at that point, right? So that's how, say, they are associated. Now, if we just take a section, right, just to make ourselves crystal clear. So this is what? This is pons, right? That is medulla oblongata, and we see this over here, right? Over here. That's the fourth ventricle, right? That's the fourth ventricle. This one would be the anterior lobe. This one would be the posterior lobe, right? And this one is flocculus. Okay. Now, over here, we understand only two things, and then we move on to the next image. In this, keeping it simple, this big portion, right? Let's change the color. This one, this deep V-shaped, this one, that is our primary fissure. So anything above this is anterior lobe, and this one would be the posterior lobe. Fair enough, right? The next one. So that is the primary fissure. Very clearly seen over here. So that one would be the vermis. So this is anterior, that one is posterior. So they are called as the anterior notch of cerebellum and posterior notch of cerebellum. Right, anterior notch and the posterior notch. Now this vermis which is over here, it is divided into several parts, right? And we'll see to that. By the way, which view could this be? This is say anterior posterior, so this is a superior view, right? Always be oriented properly. This is superior view, right? So where we see the things properly. Okay, moving further. Say still all these areas, right? All these areas, over these areas, they all are given the names, but we just keep it on halt. Watch this. This is which view? This is anterior view, right? This is anterior view. So we have removed the entire brainstem. So once the brainstem is removed, what will we see? We'll see that part which will be connected to the brainstem. Cerebellum has been kept intact. So only one point which is to be seen first is this area, and there is this area. They are what? They are cerebellar peduncles, right? They are cerebellar peduncles. So we have superior cerebellar peduncle, we have got middle cerebellar peduncle, and we have got the inferior cerebellar peduncle. So these are cerebellar peduncles, right? Because we have removed the whole brainstem to make things easy. This fissure which is going all the way absolutely horizontal, so horizontal fissure, right? Horizontal fissure, that is easy. This in between, this portion, that is all vermis, right? So now the vermis is starting from here, right? Say vermis is starting from here and all the way it is taking turn posteriorly and then it is coming back, right? So that's how this vermis is situated. So, right? Because they see the entire portion to is connected. That's how we drew it, no? We drew it. Right, this anterior portion is so connected. So vermis has to start from here, all the way, and then it reaches at the end. So that is the connectivity which is in between. So that's how vermis is there. Okay, this one would be the posterior notch. The posterior notch. Yes, all these vermis, they have got parts, but we'll take it separate. Right. Those tonsils, they are seen so nicely. See this big tonsil, this one, this area, that is the tonsil, right? Tonsil of cerebellum, So horizontal fissure, tonsil of cerebellum, and superior, middle, and inferior cerebellar peduncles, right? Now we go for full-fledged details of the vermis. So for the sake of convenience, what has been done is, say, shape of the vermis is like this, right? Is like this. Instead, we have just opened it. This 3D structure has been made 2D, so that full-fledged, right from the top to bottom, everything can be seen in one plane. So as if it has been stretched open, right? Let's start. Such crazy names, but very easy to remember, right? Let's start with this top one, first one. This is tongue-like projection, right? So it is called as the lingula. The second one, which is over here, second one. Now you must have seen that, say, the colors are different, right? The colors are different because this portion, this is our fissure, So it is primary fissure. The moment we say this is primary fissure, things are easy, right? Because this is primary fissure, that means we are talking about above, we are talking about the anterior lobe, right? So the vermis of anterior lobe, that is having these parts. One, lingula. The second is what is called as the central lobule, right? Central lobule. Right? This third one over here is called as culmen. To remember, this is like loving, caring children. That's our anterior lobe, right? That's our anterior lobe. So we have lingula, central lobule, and lingula, central lobule, culmen. So this is primary fissure. Now from primary fissure we go down. So that means our next one, right? Now see, there is associated. The name of these areas are different. We are only talking about vermis at this point. Right? We are just talking about vermis because this is the only thing which is bit complicated. Otherwise, the rest is all easy. So here we are talking about only vermis. We are talking about only vermis. Right? So lingula, central lobule, culmen. Next one. They do what? Loving, caring children, they donate. Right? So they donate. So this D is decline. This is the portion which is decline. So it makes complete sense when I say that primary fissure divides culmen and decline, right? Primary fissure divides culmen and decline. So that's decline. They donate to what? They donate to, so they donate to the next area. It is this area, right? All are coming one after the other. That is called as the folium, right? That is called as the folium. Just keep some space to, this is called as the folium, right? Just let's change this thing. They donate food. Now it is fine. They donate food to. They donate food to. So the next one should start from T over here. Over here. So it should start with T, and this T is tuber. Tuber. Now when this, the between folium and tuber, right? Here it is, this one. Or let's draw it in on the opposite side. Between folium and tuber. This. That's the horizontal fissure. Right? That's the horizontal fissure. So tuber done. Total there are 9. So 1, 2, 3, 4, 5, 6. 6 down, 3 to go. 2. To whom? To poor. Someone who has not eaten anything, so unfed. And someone who is needy. Right? So this. Now this needy, N, this is nodule, right? Nodular. So you remember flocculonodular? Same thing is coming up. Okay. The next one over here after tuber, this is P. So P is pyramid, right? It is pyramid. The next one over here, this is U. U is uvula, uvula. And the last one, that is nodule, right? Nodule. This is flocculus. So combination of this flocculonodular part, that is called as flocculonodular lobe, right? So this purple color, this is all part of flocculonodular lobe. This one, right? That is flocculonodular lobe. So here it is. We have got now all the parts of this vermis, right? To make things a bit easier, I put a table. So we'll add something to this table to make it still easier. So here it is. Say anterior and posterior lobes. So this will be the point where there would be the primary fissure, right? This one would be the primary fissure. Primary fissure. And where was that horizontal fissure? Horizontal fissure was between this folium and tuber, right? This is the, so here it is. Here it is, right? It is actually this one. This one is the horizontal fissure. This one. Now it is okay, right? So that one is horizontal. Horizontal is situated. So between folium and tuber. So between folium and tuber, that one is horizontal fissure. So here is folium and tuber. Between this one would be the horizontal fissure. Rest is all very self-explanatory. What it is? So this is the vermis. So this is lingula, central lobule, culmen, nuclei, folium, tuber, pyramid, uvula, and nodule. All of them the way we learnt it. The function of vermis, why it is so important? Because its function is that touch, hearing, sense of balance, right? Touch, then say hearing, balance, right? All those fine movements, they are the functions of vermis. So this lingula has got no lateral extension, right? This is like a tongue-like projection, tongue. That's why lingula name. Central lobule, right? So when I say lateral, so this lateral, this is lateral. This is the lateral portion. This one is lateral. This one is lateral portion, lateral extension of, say, this vermis. So central lobule's lateral extension, it is called as ala, or it can be called as the wing of central lobule. So central lobule, which is part of vermis, and then this is on its side, right? Then culmen. Culmen, this is the largest, right? Is very cunning, right? So it is largest. Quadrangular lobule. Then we have got, so this finishes our anterior lobe. So in anterior lobe, we have got the lingula, central lobule, and the culmen. For the posterior lobe, right, here is the horizontal fissure, right? So in horizontal fissure, we have got the declive and folium. Declive, right, its lateral extension is lobulus simplex, or in simple words, simple lobule, right? Simple lobule. You can very well write it like simple lobule. Then folium, right? Folium is smallest, right? So it is linked with superior semilunar lobule. So where is superior semilunar lobule? Find out folium. Here it is folium. This one, right? That is superior semilunar lobule, right? So if that is superior semilunar, and then there is horizontal fissure. This one is horizontal fissure. So this one would be the inferior semilunar lobule. Correct. And this inferior semilunar lobule is associated with tuber. Let's check it out. Yes, here it is. See, it is associated with inferior semilunar lobule. Next is pyramidal, that is biventral lobule. These are all the names, right? But once you coordinate this image along with this table, everything would be set, right? And then uvula associated with tonsil. And now comes our third fissure. This is the fissure. This is the fissure where this we said this is anterior lobe, that one is the posterior lobe, and collectively anterior lobe and posterior lobe they are called as the corpus cerebelli, right? And this third fissure, that is called as the posterolateral fissure. And this posterolateral fissure, this is nodule surrounding its lateral extension is flocculus, and combination of both the things is called as this tongue twister flocculonodular lobe. Done, right? So this is how the entire cerebellum that is distributed, correct? So just do remember this part, that loving, caring children donate food to poor, unfed, needy, right? So that's how it is this, right? So this is loving, that is lingula, caring, right? That is central lobule. Children, right? Children, so that one would be culmen. They donate, so that is declive, right? Food, so that is folium. Tuber, so two. Pyramid, so this is to poor. Uvula is unfed, and nodule is finally who is needy. Done, right? You just write this thing 2-3 times, that's it, right? You'll never face any problem in future. Moving on to the very vital component of this cerebellum, sorry, and that is called as the cerebellar. Let's save some space. This is called as the cerebellar nuclei. Cerebellar nuclei, right? Now these nuclei, which ventricle will come over here? Obviously the fourth ventricle, right? Because third ventricle though is very high, here the fourth ventricle. So this is the fourth ventricle, this one, right? This one, that's fourth ventricle. Fourth ventricle. See how correctly the name has been given to these cerebellar nuclei. Because these nuclei, they are into the roof of fourth ventricle, right? They are into the roof. The cerebral nuclei, they are also called as the roof nuclei. Roof nuclei. Reason? They are into the roof of fourth ventricle, right? 4 nuclei are there. One who is big, really big, and these tooth shaped, right? I don't know whose teeth are like this, right? Such bad teeth, but still, this is called as the dentate nucleus. Dentate nucleus, right? No big rocket science, just by looks also we know that it is the largest, right? So that is what is called as the dentate nucleus. We'll go into the detail. First, let's understand. By the way, this is what this one would be, the vermis, right? This is vermis. We just saw it, right? Which is connecting both of them. So that is vermis. So when we have taken the section, right? So we are watching these nuclei. Acha, this one would be the superior cerebellar peduncle, right? Superior cerebellar peduncle. This one, right? Acha. What about this portion, right? Lingula, right? Lingula, this one, lingula. So, okay, let's write here, right? Lingula. So we were talking about all those nucleus, and this first one is the dentate nucleus. Now from lateral side, as we go inside, the next one which is coming, right, that is called as the emboliformis. This part, this one, it is called as emboliformis. We'll be going into the detail of all this, but first let's identify. So this is emboliformis nucleus. So this is second one, right? The third one over here, that one, right? It is globose. So this is the third one. We are trying to go from lateral aspect to the medial aspect. So that is globose nuclei. And the fourth one, right, this fourth one, that is fastigial. Fastigial, right, nucleus. So these are the four nuclei of cerebellum. All of them, they are very, very crucial. So let's see what exactly they do. This understanding will help you a lot when you will be examining the patients who have got some problem into the cerebellum, starting with dentate, right? Dentate, which is the largest, right? No need to write also, but it's okay. It is the largest, you know. Now we'll also be learning cerebellum from its development point of view. That how means way back when there were only fishes, right? So they were not having this such a big beautiful cerebellum, right? Only a portion of it. So those cerebellum, they are divided into several parts. We'll see that. But this dentate nucleus is part of neocerebellum. Neocerebellum. This is a newer cerebellum which is present in us, right? Which is present in us. So this looks like a crumpled thing, right? Crumpled thing. But its importance is, and we talked about it, it carries most of the fibers from superior cerebellar peduncle, right? This is what it does. Most of the fibers from superior cerebral peduncle, they are via this dentate. The second one is emboliformis. Emboliformis. This emboliformis, you saw that it is quite oval. Right? It is oval. And this is a part of paleocerebellum. Paleocerebellum. So this emboliformis and the next nuclei, which is the globose, right? Globose. They both are quite similar, right? Very similar. That's the reason that when we say emboliformis and globose, so sometimes they are collectively called as the nucleus interpositus, right? It is called as interpositus. These are the nuclei which are sitting between dentate and fastigial. In between they are sitting, right? So it is interpositus, emboliformis and globus. The final one, which is the fourth one, right? That is fastigial. Fastigial. Now this fastigial, the biggest nuclei was dentate, right? Biggest one was dentate, no doubt about it. Then smaller than dentate is fastigial. And the smallest are the nucleus interpositus. It means both of them, right? Emboliformis and globus, both of them. And this is the part of very old archicerebellum. Now this fastigial, it's very interesting. It is associated with vestibular system. So that's why it will be playing a leading role into the balance, right? Vestibular system. So phylogenetically means that as it developed, right? As it developed gradually, right? So initially there were only fishes. So archicerebellum, it is considered as the oldest, right? Archicerebellum is the oldest. This is part of, say, vestibular system. So initially it was very much necessary to balance the body, right? Rest of the higher functions, etc., they came at a later stage. So this is the oldest. And in whom it was found? It was found in all those aquatic vertebrates, right? Aqua is water. So aquatic vertebrates. Vertebrates means those who are having vertebra, right? Vertebrates. So for example, fishes, they were having this, right? So this is, its function is vestibule. The moment vestibule comes, its function becomes equilibrium, balance, right? Balance. That's the equilibrium. Then the posture, right? The posture. Actually, the tone also, the tone of the muscle. All these things, they are handled by this archicerebellum. So basically, it is how much flocculo-nodular lobe, right? The last end, and lingula, lingula, the the beginning, right? So those lovable beginning, and the last one needy, right? That's the end. So only those two ends were there, nothing in between, right? So this is the part of archicerebellum. Then things develop further, right? There came paleocerebellum. Paleocerebellum. Now this was, you know that initially there were fishes, then gradually they started coming out, right? They coming out and they started moving on land. So they were called as the terrestrial, right? They were called as the terrestrial vertebrates. Terrestrial vertebrates. So when they came on ground, there was much more requirement with the communication with spine. So that's why this part is also called as the spinal cerebellum. What was needed? Because when you are on land, see, in water things are different, but when you are on land, so then tone, posture, right? That was important. But at the same time, for the first time, they started walking, right? So the limb movement. When fishes, they were swimming inside, there was no involvement of any limb. But when these terrestrials, they came on land, right, they were supposed to walk. So initially that walk was very crude. There was no very fine, ultra sophisticated movement. No, there were crude movement, right? The way dinosaurs used to walk, right? So that was a crude limb movement. It is only when the neocerebellum came into picture, neocerebellum, right? Neocerebellum, when it came into picture, and this is what is called as the, when it started communicating with cerebrum, right? So that's why it is called as the cerebral cerebellum. How interesting, right? Cerebral cerebellum. And what was its function? Finer control, right? Fine control. And with this fine control came the language, right? Came the language. So now picture is very clear that why those dinosaurs, they were not speaking, right? Because of the lack of that neocerebellum. And then not only that, it was not only the cerebrum, but it started talking with the rest of the brainstem also. So it was cortico, ponto, cerebellar connection, right? That's how it is said. So this was for all those smooth movements, smooth movements. And this is where the whole of the cerebellum developed, right? So this is what is called as the phylogenetic. On to the blood supply, right? We move on to the blood supply. Now, if you know the circle of Willis, then blood supply is super easy, right? We'll make it still easier. Let's draw, right? Instead of that theory part. Brain is supplied by internal carotid and the vertebral, right? Those vertebral which are from the backside. So here is the vertebral, here is the vertebral, and then both of them unite to form basilar, right? So this is vertebral and this one is basilar. Both of them, they unite. This basilar will divide into two parts, right? This, and that is the posterior cerebral, right? Because it is the posterior cerebral, and this posterior cerebral will then communicate with the middle cerebral, which is part of that internal carotid, right, by that posterior communicating artery. So we don't need to go that much over there. Our entire purpose will be fulfilled in this only. The cerebellum, right? It is very nicely. So this think it like this. This is cerebellum, right? It has got the superior surface. It has got the inferior surface. inferior surface is divided into two parts. So this is the superior surface and this one is the inferior surface. This is the anterior part of inferior surface. This one is the posterior part of inferior surface. Okay. So here are the arteries, right? We are drawing the arteries in white color, just for the understanding. The first one which is part of the basilar artery, right? You remember posterior cerebral artery, but then there was another artery which was coming out. This one is superior. This is superior cerebellar artery, right? This is one, and this superior cerebral artery will supply the superior portion of the cerebellum. Okay, simple. Then the second artery, which will once again be coming from basilar but from the lower end. This is the second one. This is anterior inferior cerebellar artery. So this is anterior inferior cerebellar artery. Anterior inferior cerebellar artery, yes, it has to supply the anterior portion of the inferior half or the inferior surface of the cerebellum, right? Anterior part of the inferior surface of cerebellum. So this part, right? This part. This third one, so its name should be posterior inferior cerebellar artery, and that posterior inferior cerebellar artery is a branch of this 3, right? This is vertebral, right? That's vertebral. So this is the branch of vertebral artery. This is the posterior inferior cerebellar artery, which supplies posterior part of inferior surface of cerebellum, right? Pretty easy, right? So that's it. This is about the chota dimag or the cerebellum. Next time we'll be taking the complete clinical aspect, because that clinical aspect is so rich, right? So all you need to do is just to next time, I think tomorrow, tomorrow when we meet, right, we'll be discussing the clinical aspect, the complete clinical aspect, including all the tests, and we'll watch some CT, MRI also, right? So till that time, just revise this part very properly so that when you really look at CT and MRI, you'll find it much easier, right? Thank you so much, and see you tomorrow, right, where we'll be talking about the second part or the clinical part of cerebellum, right? Thank you, and bye-bye. And this file has been saved and I'm putting into our shared folder.